Hi, it's great to have you back here on God Maths, where mathematical literacy begins. We continue with our lesson on differentiation, and in this lesson, we will learn how to find the derivative of implicit functions. Stay tuned. So far in our lesson on differentiation, we have come across explicit functions. Explicit function means that in that function, one of the variables can be made the subject in terms of the other. Consider the two functions here. In the first function, y is expressed in terms of x. Now in the next function, even though y is not expressed in terms of x, we can make y the subject of this function by dividing both sides of the equation by x, so that y will now be equal to 3 plus x squared all over x. Therefore, y has been stated in terms of x, and so we call these two functions explicit functions. But there are some other functions where it will be extremely difficult to make one variable the subject in terms of the other. Consider the two functions here. It will be extremely difficult to make y the subject in any of these two functions. And so these functions are called implicit functions. Today we will look at the techniques that can be used to find the derivative of functions that are implicit. Let's consider the function x raised to the power 3 plus y exponent 2 is equal to 3y. And we want to find the derivative of this function. It will be seen clearly that y cannot be expressed in terms of x, and so we will call this function an implicit function. Suppose we want to find dy dx, which is the derivative of this function. Now, let's take the derivative of each term of the function. That is, we will find the derivative of x cubed, which we will call d dx of x cubed, plus the derivative of y squared, which is d dx of y squared, and that is equal to the derivative of 3y. Now, d dx of x cubed means we want to differentiate x cubed with respect to x. And so, when we differentiate x cubed from the general rule of differentiation as discussed in our previous lessons, x cubed will give us 2x squared, 3x squared. That is, we multiply the function by the power and then we subtract 1. Plus, now we want to differentiate y squared, but we want to do that with respect to x, where there is no x in this function, and so this becomes impossible. But we can write d dx as d dx is equal to d dy times dy dx, so that when dy cancels dy, then we will be left with d dx. So we will write this as d dy times dy dx of the function y squared, and that is equal to, since this is also in terms of y, we have d dy times dy dx of 3y. Then we have 3x squared plus, here, since this is in terms of y, we can find d dy of the function, which means that we will now be left with d dy of y squared times dy dx, and that is equal to d dy of 3y times dy dx. So we will have 3x squared plus d dy of y squared, that is the derivative of y squared with respect to y, will give us 2y using the general rule of differentiation. And this is multiplied by dy dx. Then that is equal to d dy of 3y using the general rule will give us 3. And that is also multiplied by dy dx. Remember that we want to find dy dx, which is the derivative of the function. So we make dy dx the subject, where we will have 2y dy dx minus 3 dy dx is equal to, we send this across to have negative 3x squared. So finally, by making dy dx the subject, we will have 2y minus 3 all multiplying dy dx is equal to negative 3x exponent 2. And then we will have dy dx to be equal to negative 3x squared divided by 2y minus 3. This is the derivative of the implicit function given above. We will take other examples to learn more in this technique. Now let's consider this function. We want to find the derivative of the function, which is also an implicit function. So in finding the derivative, we take the derivative of each term of the function. And so we will have d dx of x squared minus d dx of the function 3y cubed, and that is equal to d dx of y squared plus d dx of 5, where we know that the derivative of a constant is 0. So d dx of x squared using the general rule of differentiation will give us 2x. Then minus d dx of 3y cubed. Since this expression is in terms of y, we can't find the derivative with respect to x. And so, as we obtained from our previous example, we will find dy dx times d dy of this function 3y cubed, where we know that dy dx times d dy, when dy cancels dy, we have d dx as we have here. And that is equal to, since this is also in terms of y, we do the same thing. We have dy dx times d dy of y squared. And the derivative of a constant is 0. So this simply means that when we have the function in terms of y, then we will rather differentiate it with respect to y and multiply the answer by dy dx, which will give us the same as d dx of the function. So from here we will have 2x minus dy dx times, when we find d dy of this function, we will have 9y squared using the general rule of differentiation, and that is equal to d dy, that is dy dx of, when we find d dy of this function, we will have 2y. Then, since we want to find the derivative, we make dy dx the subject. And so 2x will be equal to, we have dy dx of 2y plus dy dx of 9y squared. Then 2x is equal to, we have dy the x out, then we will have 2y plus 9y squared. And so finally, our dy dx will be equal to 2x divided by 2y plus 9y squared. So the general technique we have learned here is that if we want to find d dx of a function in terms of y, then we will find d dy of this function, which will give us 4y, and then we multiply d dy by dy dx. Let's check out another example on this. So this is our third example under differentiation of implicit functions, where we want to find dy dx given the function x squared plus y exponent 3 is equal to xy. Now let's check the solution to this. Now in differentiating implicit function, we have to find the derivative of each of the terms of the implicit function. And so we will have d dx of the function x squared plus d dx of y exponent 3, and that is equal to d dx of xy. d dx of x raised to the power 2 will give us 2x plus d dx of y exponent 3. As done in our previous examples, we will differentiate this with respect to y, which will give us 3y squared, and then we multiply the results by dy dx, and that is equal to, note that this is a product function, and so we use the product rule of differentiation as done in our previous lessons to find the derivative of this. Now in the product rule of differentiation, we differentiate the first function and multiply the result by the second function. Then we differentiate the second function and multiply the results by the first function. So when we differentiate this function, d dx of x will give us 1. Then d dx, we will multiply this by the next function, plus we will multiply the first function x by the derivative of the second function, which is d dx of y, and that is going to give us 1 dy dx. You can refer to our lesson on the product rule of differentiation for more clarification on this. So from there, we will have 2x plus 3y squared dy dx, and that is equal to y plus x times this will give us x dy dx. We make dy dx the subject, and that means 3y squared dy dx minus x dy dx is equal to y minus, we move this to the other side, we have 2x. So finally, we will have 3y squared minus x, all multiplying dy dx. That is when we factor dy dx out. It's equal to y minus 2x. So finally, we will have dy dx to be equal to y minus 2x all over 3y squared minus x. We will take our final example on the differentiation of implicit functions. This will be our last example on the differentiation of implicit functions. And we are given the function xy squared is equal to 2y plus x exponent 3, where we want to find the derivative of the function with respect to x. So as we have done in our previous examples, we find the derivative with respect to x of each term of the function. These are the three terms of the function. So d dx of this term, d dx of the next term, d dx of the last term. Where we know that d dx of x cubed, that is differentiating this with respect to x, will give us 3x squared from the general rule of differentiation. You can refer to our previous lesson on that. Then d dx of 2y, as we discussed in the introduction to this lesson, d dx of 2y is going to be d dy of 2y times dy dx. So we find the derivative with respect to y, which will give us 2. Then we multiply our results by dy dx. Then this is a product function, and we have already done the product rule of differentiation, where if you have two functions multiplying, so this is x, y squared. Now this is our first function and this is our second function. And the product rule of differentiation states that in finding the derivative of this function, we differentiate the first function and multiply the result by our second function, plus we differentiate the second function and multiply our result by the first function. So in effect, when we differentiate the first function, we will have 1. Then we multiply by the second function, y squared, plus when we differentiate the second function, we will have 2y dy dx. Then we multiply that by our first function, which is x. So this is what has been done to find the derivative of the product function here. So from there, we simplify the terms. Then, since we want to find dy dx, we group all terms that contain dy dx. This cross to become minus 2 dy dx. Then we factorize dy dx out, and then divide through by 2xy minus 2. Then finally, the derivative of this implicit function will be dy dx is equal to 3x squared minus y squared all over 2xy minus 2. I believe you have enjoyed our lesson on implicit differentiation. We will take one question as assignment for this lesson. Now you try these questions on your own. If you encounter any extra difficulty, you are always free to WhatsApp us, or you are free to contact us via any of our social media handles. The number is displayed on your screen. The social media handles are also displayed on your screen. Remember to subscribe to this channel for more interesting lessons. In our next lesson, we will discuss how to differentiate parametric functions. See you in our next lesson.